чат из облаков, координаты солнца. Заинтригованный весь восток, японцы смотрят в телескоп. Поток сознания плывет.
This portion of the lesson will cover how to properly start a Ka-50 Black Shark helicopter. This will be the long version of the start sequence, which means we'll have all major systems running before we taxi out. In the next lesson, we'll see how to quickly get this bird in the air, leaving some of the systems to be turned on after liftoff. That will be useful in missions where there's little time to get going. I will be using the checklist included in this training package, so have it handy as we go through the startup. First, ensure the parking brake is on. It is normally already on when we initiate a mission, so all you might have to do is check. The parking brake is activated by a handle in front of the cyclic stick and by the keyboard shortcut left shift and W. Having the brakes on will keep the helicopter from moving as the rotor starts to generate lift. I will show you if I hit shift W and shift W again. This position means the parking brake is engaged. We will take a look at using external power. Even though this external power might be readily available, we will need to turn our batteries on before it can be connected, as we need to establish contact with the ground crew and request that connection via the SPU-9 intercom. The Ka-50 has two independent batteries, controlled by switches on the forward section of the wall panel. They are both capped, like many switches in this helicopter. So, go ahead and left-click on the covers to move them up, then left-click on the switches to move them to the on or up position. You will hear a subtle sound of avionics equipment and cooling fans spooling up. Recap both battery switches, as they will stay on for the remainder of the flight. Now, let's provide power to our SPU-9 intercom by flipping the INT-COM switch up. This switch is located on the wall panel as well, but a bit further back from the battery switches. It will allow us to speak with the ground crew while on the ground, but also to hear the aural warning we will get during our LAMPS test, which will be next. With our intercom energized, we need to select ground crew on our SPU-9 radio communicator selector by turning this knob. Remember that right mouse clicks rotate knobs clockwise, while left mouse clicks rotate them in a counterclockwise direction. Seeing as the knob is on the CA VHF2 position, let's right mouse click 3 times. Okay, our intercom is powered and set to the proper communication channel. So, let's hail the ground crew. In DCS Black Shark, you can bring up the communication menu by simply hitting / on your keyboard. It's important to remember this keyboard shortcut, as there are no switches, buttons, or knobs in the cockpit that you can click on to bring up this menu. So, let's hit /. The communication menu pops up on the top right of the screen. By looking at the available options, you can see that the one we are interested in right now is activated by pressing F10 for maintenance. After pressing F10, the menu changes to the maintenance communication menu. As you can tell, maintenance can do some pretty interesting things, like rearming, refueling, and even swapping out our helmet gear. These are all covered in future lessons. For now, let's hit F4 for ground electrical power. Once again, we find ourselves looking at another menu, although this one is simpler. You can either hit F1 to connect external power, F2 to disconnect it, F11 to go back to the previous menu, or F12 to exit the communication menu. This last option can also be achieved by hitting the escape key on your keyboard. Hit F1 to request a connection.
501. Request to turn on ground power. Okay.
You will hear yourself, or better yet, your virtual self, requesting the connection over the intercom.
Ground power is now on.
And 2 responses from the ground crew. The first that they have copied your request, and the second that the connection has been made. You may have noticed that nothing in the cockpit really changed after this connection. Fear not. The helicopter is indeed receiving external power, but you have not allowed it to spread through the systems. To do that, you need to flip 2 more switches, one for the DC power and another for the AC power. These switches are also on the forward portion of the wall panel, right by the battery switches. The external DC switch is guarded, so uncap it and flip it up. The only indication that this has worked and that indeed external power is connected to your machine is the external DC power light, located right next to this switch. Recap it. Now let's turn the external AC power on by flipping the external AC switch, which is unguarded. The external AC power light, which is right under the DC light, will come on. Notice that when it comes to the external power lights, DC power is indicated by the equal sign, while AC power is indicated by the tilde sign. This is a common electrical notation for both types of power. It is now time to get our ECRAN up and running. The ECRAN is a monitoring system that can alert the pilot of cautionary, abnormal, or emergency conditions the helicopter and its systems might be in. Let's look at our rear auxiliary panel, where we will find the hydraulics, transmission group, and ECRAN sensors power supply switch. It is already uncapped, so we flip it down to turn these systems on. We can now cap it and return our attention to the forward panel. Notice that the master warning light push button is blinking. Press it once to acknowledge the warning, then a second time, which will initiate the ECRAN self-test. After about 5 seconds, if successful, the ECRAN will display the ECRAN ready message. Next, we will do a lamps test. Note that if you did not require external power, you would simply go from turning the batteries on to performing the ECRAN test to this lamps test. The purpose of the lamps test is to ensure every normal, caution, and warning lights present in the cockpit are working. This is to guarantee that should a problem develop during the start, the associated lamp indications would function to alert you of that problem. While we perform this test, you will be required to look at lamps that are spread out throughout the cockpit. This is possible in DCS Black Shark even if using the mouse to click, since after clicking on a button, you are allowed to move the cursor away from that button and it will stay pushed in as long as you do not release your mouse button. We will start from the rear left of the cockpit and perform a scan flow from left to right, following the sequence indicated in our checklist. The push button to initiate this test is located on the upper left of the left forward panel, right above the MWS-LAS JAM protection switch, and it is labeled WL/ADV lamp test, which stands for Warning Lights Advisory Lamp Test. You will also be able to control your zoom factor by using your mouse scroll wheel while you look around, but start by setting a pretty zoomed out state. Push and hold the lamp test button down. You will hear an aural alert, which is the alarm sound for the rotor RPM warning. This will sound throughout the test. Since we're going to spend some time looking at the warning lights, we don't want this sound going off, so let's turn our intercom switch off, which can once again be done on the wall panel. Intercom off, and back to the lamps test. Rotate your view to the left rear, and we will start the lamp check flow by the 4 APU lights located on the APU control panel. We are looking for 4 green lights: APU valve open, APU oil pressure normal, APU NMAX shut off, and APU on. After that, move on to the engine startup control panel. Here, we only have the start valve green light to check. From here, we move up onto the left forward panel, first checking 3 green and 3 red lights on the gear position indicator, then the rotor RPM warning, and master warning push lights. Above and to the right of the altimeter, we have the left forward panel caution lamps. They are 11 lamps in total, arranged in 2 groups, one of 9, the other of 2. The lights to check for here are left-hand engine overspeed, right-hand engine overspeed, over G, left-hand engine vibration, right-hand engine vibration, indicated airspeed max, main gearbox, fire, and IFF fail above the altimeter, and laser warning and extend gear to the right of the altimeter.